Alright, hi, Hunter and Alex today. We're looking at a problem that we did just at the close of yesterday's lesson. And we're launching something, I'm trying to decide what it is. What can we launch? How about a missile? Alright, we're launching a missile. It's only going 12 meters per second, so it's not going to do a whole lot of damage. So we have a missile, it's aimed at 30 degrees, and we are going to give it an initial velocity of 12 meters per second. That's the yellow vector, that if you can tell where the yellow one is on the video, this is the yellow one. Alright, so the question is find the maximum height. Would you jot down the missile problem? You've just been hired by Aberdeen Proving Ground to do this kind of thing. So what's the maximum height of the missile? You're trying to shoot down a rogue blimp that's flying across the sky. So here's the one you've chosen, and we need to know the maximum height. Alright. Did you hear about all the guys shooting and at the blimp? You know, I mean, these were you know, law enforcement people. They must have had the best fun. I'd be afraid it would blow up, though. You know, I just don't know what kind of gas would initiate that. But yeah.
Actually, I don't know why they would be shooting. I don't know what they were shooting at it, but it's actually designed to take bullet holes.
But yeah, well then, so go figure. And it was also designed never to get loose. So it was designed, the tether was designed to withstand 100 miles per hour wind, and it had 40.
They had a picture at APG, it was like, now at APG, and it's like a class being taught on how to tie ropes. I was like, that's rough, that's rough.
I was always thinking maybe someone snuck there and like cut it, but I guess they would be able to tell them that it was tampered with, but alright, they're so ugly up in the sky and ominous looking. I can't be sorry that now there's only one. Alright, the blimp that's there just heard me say that, so if I don't show up tomorrow, you'll know why. Alright, let's look at this missile that we're aiming at an undisclosed object. So let's find the maximum height. And the way we do that is we always start and we answer the question, is this a question in X or a question in Y? Question in X's, we're going to look at distances that are values this way, Y this way. So Brandon, is this a question in X or Y? We're looking for the maximum height.
And that will be a...
So right here is going to be the maximum height.
Well, I mean, you know why they would be zero, so it's a X.
No, because that's true, the Y component is 0, but forget about the components right now.
Yeah, you're looking at, you want to know
I want the height of the
yes.
missile.
Y, yes.
Alright, so first decide whether it's a question in X and Y. Maximum height questions are always a question in Y. So now we start our little list of things that we know, V, V sub O, X, A, and T, and have them in any order that you do. And now we go by and we put in little y's, because now we have to do this all in terms of y. So can those little y's show up, Zach, in the video?
Yes.
Alright, so notice I have, how cool is this, a V sub O sub y. So, alright, V sub y, X sub y, A sub y, T sub y. Now we're going to go down and identify which ones we know. And if we know the numbers, we're going to fill them in. We're not just going to check them off this time. We're going to actually fill them in. So, do we know the velocity initial in the y direction? This is the place where the students make the most mistakes. So, the velocity at initial in the y direction. Do not say 12. So what should we say when we are asked about the y direction? We are asked to find this green arrow, because that's the velocity in the y direction initially. So we have to pull out a trig function. Which trig function is it, Emily, number 1?
Sine.
Alright, so we're going to say sine 12 sine 30. we are well taught that sine will give us the y component, or the opposite side of the triangle. So what is 12? I think it's 6, isn't it?
Yeah.
All right, so because sine is 30 is half. So half of, if you check that on your calculator, if you're in degrees, make sure that it is 6. Velocity y final. We're going to cut this problem off right here and say this is the end. We're not going any farther. We have established that the velocity of the y component at the end of the problem is 0. Now we want the distance in the y direction. That's what we're looking for, and that's the height. What is the acceleration in the y direction? Someone told me, I think, earlier. It's always negative 9.8 when you're working in meters. And the time is unknown. So what equation do we have that doesn't have time, just like yesterday? It's the squall. The very worst squall is the very first squall, and it comes like 2 x's. All right, so go ahead and plug those numbers in. We've got a nice list here, just plug them in and solve for x. That's what we're looking for.
Got
Got an answer?
1.8.
All right, let's see if it can be confirmed. Anyone else get to that? It is?
I'm not there yet.
All right, check it. 1.8, and that's in meters. So, all right, so that's how you do maximum height problems. Not too bad. We did one yesterday and one today. You won't really know if you understand it until you do the whole thing by yourself, which is only moments away. So, I know the anticipation is mounting. Go back to this scenario from yesterday and sketch another one of these. We're going to have the football 45 degrees. And what else do we know about that? From the football. Let's look at, it was 15, wasn't it?
Mm-hmm.
Meters per second. All right, it had initial velocity of 15 meters per second. It was launched at 45, and I'm going to change that because I was doing the y component in green, so I'm going to keep that in yellow. Picky, picky. All right, 15.0 meters per second. And now I want to know how long to reach the receiver, who is 23.3 meters away. Because we have already started in meters per second, so I won't mess with that. How long to reach the receiver? 23.3 meters away. Right, we're going to use the same sort of idea that we did over there. First of all, we have to realize how long is a time. It almost looks like a distance, but that's the way we ask time questions. How long does it take you to wake up in the morning? So it's a time question. How long to reach the receiver? 23.3. So recognize this is a question about time. That's what we're looking for. And the question about time, is it this way? Are we asking about an aspect of time this way, or are we asking about an aspect of time this way? So we have to start with that same question, x or y. So on this one, what do you think, Emily Davis? Emily number 2. I do this to you every day. I put you in danger. All right, because...
I think there's about 1 million of them in the world.
Yeah.
All right, so here we have a question about when and how much time for it to reach here. You see my hand went horizontal. It's a question in x. Is that what you said?
Yes.
All right, so it's a question in x. So we're going to do our 5 values, v sub o, v, x, a, and t, but we're going to do them sub x this time. So I'm putting in my little sub values. And I'm going down the row. So let's see if we can do that. All right, Brandon, we'll just go around the room. Everyone gets one. What is the value of velocity initial in the x direction on this problem? here's a picture of it right here. But how do I see, here's the initial velocity, but I want only the x value right here. So what would this value be? How could I find it? It's a trig function that I need.
I mean, I know, for example, when you look 15 and sine
Right, so what do you-
45, but if you only want the x, you would do 15 cosine 45?
Exactly.
Right?
And I think 15 cosine 45.
It's exactly the same as 15 sine 45.
Okay, and I forget what was it, 10.6? All right. That's because that's sort of God's little joke to us mathematicians.
It's 45
Cosine of
degrees.
45 and sine of 45 will always give you the same. So, all right, let's look at the velocity in the x direction. So, I mean, velocity initially in the x direction, and then velocity final in the x direction. Brian, what would your thoughts on that?
My thoughts on that?
Velocity final, so that's down at the end of the
so-
story in the x direction.
Final velocity. That's
In
what we're
the
trying to
x
figure out.
direction. Nope, we're not trying to figure that out, but we're going down our list and seeing what we know
The
and what
final
we don't.
velocity would be still 15, right?
It wouldn't be 15 because we are only working in x.
Oh,
But it
so
would
it would
be-
be 0.
No, you were on the right track when you said 15, but I'm talking about the velocity final in the x direction. So remember, it
The x
never
direction.
changes.
Oh, so it would be the same as the original
Right.
velocity?
Right, so it's the same. We usually will not need both of these in an equation, because if we do, they'll cancel each other out and won't give us what we're looking for, but it is true. All right, so Zach, your turn. The distance in the x direction, do we know that? That's what x of x means.
23.3 meters.
Right, it was given in the problem, 23.3. Acceleration, Emily, number 2, or you're 3.
0.
Right, and I already asked you, Emily, number 2, whether it was x or y, so Emily, number 1, what can I say about time in the x direction?
That's what we're trying to find.
Alright, that's what we're trying to find. So, it looks like we know everything in this one, but if you use an equation that has both these values, it will cancel each other out. So let's find one that doesn't have velocity final. Yes?
We got
How
shut down.
long's it been?
About 10-ish minutes.
Okay, let's shut it down. Alright, bye.